This lesson helps you understand the slope-intercept form of a linear function and shows how to use this form to draw a graph of the function. In a previous lesson, you learned that an equation of the form y equals mx plus b is a linear function, and the graph of a linear function is a line. In this form, the equation is called the slope-intercept form of a linear function. It's useful because in this form, the coefficient of the x variable is the slope of the line, and the constant term is the y-intercept. To derive the slope-intercept form of a linear equation, draw a set of axes and any line. Let 0, b be the y-intercept of the line, the point where the line crosses the y-axis, and x, y be the coordinates of any other point on the line. Using the definition of slope, you have y2 minus y1 is y minus b, and x2 minus x1 is x minus 0. Then simplify so x minus 0 is just x. Next, multiply both sides by x, and you have mx equals y minus b. Then add b to both sides, for mx plus b equals y. Turn it around, and you have y equals mx plus b, the slope-intercept form of a linear function. The slope-intercept form of a linear function makes it convenient to graph the function. For this function, the slope is 2 over 3, and the y-intercept is negative 2. Start the graph by drawing a point at negative 2 on the y-axis. Remember, slope is rise over run. So from the y-intercept, go up 2, the rise, and over 3, the run, to the next point. Then draw a line through the points, and you have a graph. Here's a more complete graph of the equation. Starting from the y-intercept, graph at least one point to the left and one point to the right. Also, extend the graph at least one point beyond the x-intercept. Finally, check your graph. Select an integer point on the graph like 6, 2. If your graph is correct, the coordinates of the point should be a solution to the equation. Substitute x equals 6 and y equals 2 into the equation. Then 2 over 3 times 6 is 12 over 3. And 12 over 3 is 4. And finally, 4 minus 2 is 2, and the graph checks. For equations with positive slope, the graphs go uphill to the right. For this example, the slope is positive 1/2, and the y-intercept is negative 3. The line begins at negative 3 on the y-axis and goes up 1 and over 2 to the next point. For equations with negative slope, their graphs go downhill to the right. For this example, the slope is negative 2, and the y-intercept is 3. The line begins at 3 on the y-axis and goes down 2 and over 1 to the next point. When you graph this line up 1 and over 2 to the right, you also have to graph the line down 1 and back 2 to the left. You have to graph the line in both directions from the y-intercept. When you graph this line, down 2 and over 1 to the right, you also have to graph the line up 2 and back 1 to the left. Again, you have to graph the line in both directions from the y-intercept. Here are some potential mistakes to watch for. When the slope is not a fraction, it's sometimes hard to decide what is rise over run. If the slope is equal to 2, it's really 2 over 1. So for this example, the line starts at -1 and goes up 2 and over 1 to the next point. For the equation y equals x plus 3, there doesn't seem to be a slope. You have to read this as y equals 1x plus 3. The slope is 1 over 1. So the line starts at 3 and goes up 1 and over 1 to the next point. For the equation y equals -x plus 2, there also doesn't seem to be a slope. You have to read this as y equals -1x plus 2. The slope is -1 over 1. So the line starts at 2 and goes down 1 and over 1 to the next point. For the equation y equals 1/2 x, there doesn't seem to be a y-intercept. You have to read this as y equals 1/2 x plus 0. The y-intercept is 0, the origin. So the line starts at the origin and goes up 1 and over 2 to the next point. The lines y equal x and y equals -x are so simple to graph, they're hard. You have to read y equals x as y equals 1x plus 0. The line goes through the origin uphill to the right with a slope of 1. For the line y equals -x, you have to read it as y equals -1x plus 0. The line goes through the origin downhill to the right with a slope of -1. Finally, remember to start your graph on the y-axis and not on the x-axis. It's called the y-intercept because it's on the y-axis. This lesson helped you understand the slope-intercept form of a linear function and showed how to use this form to draw a graph of the function. And this lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.